Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 5.3, day 2, entitled Trigonometric Graphs. And today we're going to continue talking about sine and cosine graphs. And we're going to focus more on a couple of the factors that affect the transformations of a sine and a cosine graph. Now, we've already talked about the amplitude, and we've already talked about how you can multiply a number and make the graph stretch a little bit taller, or you can multiply it by a negative number, and that'll reflect it around the x-axis. So the first of the other transformations that we're going to talk about today has to deal with this k value. And that is going to be our period. Okay, now the period traditionally for a sine and a cosine function is going to be from 0 to 2 pi. Okay. But this k value is going to, since it's being multiplied by the x, that affects how big your period actually is. So what we're going to do to find the actual period of the graph is we're going to take 2 pi and divide it by k. So we still have our amplitude now that we're building into our function. Remember, that's the absolute value of a. And now we have the period value, which is going to be 2 pi divided by k. So now we're building onto those functions that we had before. So it's not just sine of x anymore. Now we have a sine of k times x, or a cosine k times x. Okay. Now, when you are dealing with that k value, that is going to affect your x value in your table of values. So if you are multiplying by 2, that means you're really going to end up doing the opposite to your x values. So you're going to be dividing by 2. So notice that when we multiply by 2 here, it takes half as long for the graph to complete one period. So it goes up, and then it comes back down, and then it goes back up again. That's one cycle or one period, and it only took pi units to do it. And if we have a k value of 1/2, we're really multiplying by 2. So now it's going to take 4 pi to go up, and then back down, and then back up again. It takes 4 pi. It takes twice as long. So remember, for transformations, when we're dealing with a number that's being multiplied by the x in either the sine or the cosine curves, that's going to do the opposite in our table of values. So there you can see that we are going to be shrinking the graph horizontally if the k value is greater than 1, and we're going to stretch the graph horizontally if the k value is less than 1. So if the k is greater than 1, that graph kind of gets compressed. It all gets pushed closer together. If the k value is less than 1, like if it's a fraction, then that actually stretches the graph out. Okay, so we have a couple examples here. In example 3, we have an a and a b. And we're going to remember those values from yesterday as well. We have to find the amplitude, and then we'll find the period, which is the new concept for today, and then we'll graph it, very similar to what we did yesterday. Okay? But because we have a k value now of 3, that's going to affect our x values in our table of values as well. Okay? So the amplitude of our graph is going to be this number in front. So the absolute value of 4 is 4. And then our period is going to be 2 pi divided by that k value. So it's going to be 2 pi over 3. Okay, so that means that the graph will complete one cycle in 2 pi over 3. Now, this is where sometimes these graphs are not going to be as helpful because notice that there's no 2 pi over 3 marked on this graph. Okay, this is every quarter basically that's marked on here. So if you are going to use this graph paper, you might have to put in a few extra values, or this could be a good time to recognize that it might be easier to draw the graph yourself. Okay, so I don't know if it will let me highlight that graph and get it out of there or not. Okay, so I was able to select the graph and delete it. Okay, so now I'm just going to draw my own graph for this. But before we do that, I'm going to make my table of values. So we have x, then we have y. Okay, so now usually we start with, let me write them up here, 0, and then pi over 2, and then pi over, oh, I'm sorry, just pi, and then 3 pi over 2, and then 2 pi. Usually those are the values that we use in our table of values for cosine and for sine. And then usually cosine starts at 1, and then it goes to 0, and then -1, and then back to 0, and then back to 1. So that's our traditional cosine values. Okay. But now remember, this amplitude affects our y values. So we're going to multiply everything by 4. Okay. And then the period now is going to affect our x values. So since I'm multiplying this x here by a 3, I'm going to take all these, what do I say, standard x values, and I'm going to divide them all by 3. So 0 divided by 3 is still 0. But pi over 2 divided by 3, that's going to be pi over 6. Just think of it like a fraction if you have to. Take 1/2 and divide it by 3. Do that in your calculator if you need to. You'll get a decimal, change it back into a fraction. To do that, you do math, enter, enter, and then you'll get 1/6. So that's pi over 6, 1 pi over 6. And then pi divided by 3, that's just pi over 3. And then 3 pi over 2 divided by 3. The 3's are going to cancel, so you get pi over 2. And then 2 pi, whoops, divided by 3 is just 2 pi divided by 3. Okay, now we said that that was going to be our period. So we're going to start at 0, and we're only going to go to 2 pi over 3. So that's good. That's a good little double check that when we take all those standard values of the x values for a cosine function, we divide them all by 3, that last value that we get should be our period. Okay, so now when I graph this, okay, I'm going to start at 0, and then I'll have pi over 6, and then I'll have pi over 3, and then pi over 2, and then 2 pi over 3. So if you're drawing these by hand, that's all you have to do. Okay, just label all of those values on your x-axis. And then on my y-axis, I'm going up to 4 and down to -4. So I'm still going to start at 0, 4, and then at pi over 6, I'm going to go, whoops, I'm sorry, I started at 0, 0. 1, 2, 3. Okay, so there we go. 0, 4 is where I'm starting. Let's see if I can erase that little spot. Boop. Okay. Put my axes back in here. Okay, so now I'm starting at 0, 4, and then I'm going to be at pi over 6, 0, and then I will be at pi over 3, -4. I'm going to go back up to 0, and then back up to 4. So this graph is going to be tall, but it's actually going to be shrinked a little. Okay, it's going to be closer together, more smooshed in. I know it doesn't look like that the way I drew it, but if we put this on a more traditional graph, then it would look more smushed because this 2/3 pi, this isn't all the way to pi over 2. This is 2/3 of the way there, or a third of the way there. Okay, okay, so let's try another one, and I'm going to see if it'll let me select this graph and delete it. No, I can cut it. Okay, and then again, we're going to find the amplitude, and then we're going to find the period, and then we'll make our table of values, and then we'll make our graph. Okay, so my amplitude is going to be the number that's in front here. So it'll be the absolute value of -2, which is 2. And then my period is going to be the number that's in front of the x. So I'm going to take 2 pi and divide it by that number, 1/2. So 2 pi divided by 1/2, that's 4 pi. So again, this value here, this 4 pi, that had better be the value that I end up with at the end of my table of values. So I'm going to make that again here. Now I have a sine graph this time instead of a cosine. So I have x and then y. And normally we start at 0, and then we go to pi over 2, and then we go to pi, and then we go to 3 pi over 2, and then we go to 2 pi. So those are our normal values for a traditional sine of x graph. And then my y values are usually 0, and then 1, 0, -1, 0. So if you need to put in these little values or kind of write them off to the side if you need to, there's no shame in doing that. Okay, now remember this amplitude is going to affect all of my y values. Okay, so I'm going to multiply them all by a -2, basically. I'm going to multiply by this number that's out front. Okay, so I'm going to multiply everything by a -2. So I'm going to get 0, and then -2, and then 0. And then when I multiply by the -2 there, I get a +2, and then 0. So I know the amplitude is 2, but that's just basically telling me how far I'm going up and down. Okay, so I'm going to +2 and to -2. Okay, and then the period, remember this 4 pi and this 1/2, that 1/2, I'm going to do the opposite of that, and that's going to affect my x values. So the opposite of multiplying by 1/2 is multiplying by 2. Okay, so I'm going to take all of these x values and I'm going to multiply them all by 2. So 0 times 2 is still 0. Pi over 2 times 2, now that's pi. Okay, pi times 2 is 2 pi. 3 pi over 2 times 2 is going to be 3 pi. And then 2 pi times 2 is going to be 4 pi. Okay, so again, that 4 pi, that was my period, so that was the last value in my table of values. Okay, and now when I make my graph, okay, I'm going to start at 0, and then I'll have pi, and then 2 pi, and then 3 pi, and 4 pi. Now this graph might not have been so bad to do on the graph paper. You would have just had to extend the x-axis. Okay, and then we're going up to 2 and down to 2, or down to -2. Okay, so I'm starting at 0, 0, and then at pi I'm going to go down to -2, and then at 2 pi I'll be back at 0, and then up at 2, and then down to 0 again. So there's your sine curve. It is just more stretched out than what it usually is. It takes twice as long for it to complete one cycle. Okay. Now, before we go on, I want to go back to example A for just a moment. And I want to add in one more concept as we're doing all these graphs and they're getting more and more complicated. I want to talk about the range of the graph as well. Oops. Okay. The range for this graph then, the y values go from -4 to +4. I start up here at +4 and I go all the way down to -4. So that is going to be my range for that graph. That's important to know. That's going to come in handy. That's going to be useful information as we get more and more complicated graphs. And then for part B here, my range, okay, the lowest I go is -2, and the tallest I get is +2. So my range is going to be from -2 to +2. Okay, so still keep those concepts of domain and range in mind. Remember, our domain is going to be all real numbers because this graph technically goes back towards the negative values on the x-axis as well. Okay, and there's the nice book graphs. Notice that for part A, it does look a lot more smooshed and a lot more condensed. Okay, and part B, theirs is more spread out, like the graph I drew. Okay, so we have added and subtracted outside the function. That's what moves it up or down. We've multiplied outside the function. That's the amplitude. We have multiplied and divided inside the function. That's with the x. Okay, that's what shrinks it or stretches it out. Okay, now this last concept we're going to talk about is a phase shift. And that's what moves the function left or right. And the way we get that is by adding or subtracting a number to the x value in the function or inside the function. Okay, so this is the most complete way, I guess I should say, to write your sine and your cosine functions or your curves. Okay, we have our amplitude, we have our k value that affects our period, and now we have the x minus b that's going to affect our phase shift. Okay, so the amplitude, and then the period, and then the phase shift. Okay, now the trick with the phase shift is that traditionally the period for a sine or a cosine curve is from 0 to 2 pi. So you're going to take that x minus b value and set it equal to 0. And then you're going to set it equal to 2 pi. And then you're going to solve. Okay? So that will tell you where your graph starts and where your graph finishes for one period. So up until now, all our graphs have started on the y-axis. Now they won't. Now they'll be shifted to the right or to the left. And you know this transformation. If we subtract a number in here, that really moves the graph to the right. And if we add, it moves it to the left. Okay, so just by looking at the graph, you should be able to tell if it's going to shift left or right. You should be able to tell now about how tall it's going to be as well with the amplitude. Okay, so let's take a look at a few of these. We have example 4 and example 5. And then I have some extra examples that I can do as well for more practice. Okay, so for example 4 here, this is a shifted sine curve. Okay, so we have a 3 sine of 2 times x minus pi over 4. So instead of just sine of x, now I've got this 3 out front. That's going to be my amplitude. Okay, so the absolute value of 3 is 3. I have this 2 in front of the parentheses, so that's going to affect my period. So I'm going to take 2 pi and divide it by 2, so my period should be pi. So that's how long it's going to take my graph to complete a cycle. And then I have to do my phase shifts, okay? And there's 2 of them. So I'm going to take I could, if I wanted to, I could take the 2 and then the x minus pi over 4. I'm going to take that whole thing and I'm going to set that equal to 0 and then to 2 pi. So I have x minus pi over 4 equals 0. So if I divide by 2, I just get x minus pi over 4 equals 0. And then x will equal pi over 4. So that's going to be where my table of values is going to start. That's my first x value. Okay. And then I'm also going to do the 2, oops, that's a 2, and then x minus pi over 4, and I'm going to set it equal to 2 pi. So when I divide by 2, I get x minus pi over 4 equals pi, and then I'm going to add the pi over 4. So pi plus pi over 4, that's 1 1/4 or 5/4, so 5 pi over 4. Now that's going to be the last value in my table of values. Okay? So when I make my table of values now, I have x and y. I'm going to start with the pi over 4, and then I'm going to end with the 5 pi over 4. Now you're always going to have 5 values. You know your starting one now, and you know your ending one now. So you have 3 values in the middle that you have to find. Okay? And here's the trick how you do that. You take your period and you divide it by 4, because you have to add 1, 2, 3, 4 times to go from the first value to the ending value. Okay? So if I take pi and I divide it by 4, I get pi over 4. So that's basically what I'm going to add every single time now to fill in these other values. Okay? The other way you could do that is you could take 5 pi over 4, subtract pi over 4, and then divide by 2, so you could find the halfway point. Okay? But I think this is a little bit easier, just to take your period and divide it by 4. It's always going to be your period, and it's always going to be dividing by 4. Okay? So now I have pi over 4 plus pi over 4, so that's going to be pi over 2, plus another pi over 4, so that's 3 pi over 4, plus another pi over 4, so that's pi, and then I have 5 pi over 4. Okay? And now normally, my sine function starts at 0, and then goes to 1, and then goes back to 0, and then down to -1, and then back to 0. But my amplitude is going to change that. I'm going to multiply everything by the 3 that was out in front. So I'm still going to start at 0, but then I'm going to go up to 3, back to 0, -3, and then back to 0. The sine functions are always going to have 3 zeros in there. Always. Okay? Cosine's always going to have 2. All right, so now we just have to graph. So I'm going to start at pi over 4, which is right here. Pi over 4, 0. At pi over 2, I'm going to go up to 3. And then at 3 pi over 4, I come back to 0. At pi, I'm going to go down to 3. I'm sorry, -3. And then I come back to 0. Okay, so there's my graph. So this graph is an okay one to use the graph paper for. And again, the range for this function then would be everything from -3 to 3, because that's kind of like my max and my min of my graph. Domain would be all real numbers. We can put any number in there. Now, on quizzes and on tests and even on homework, they might have you draw 2 cycles. So that means you just have to repeat this. So let me see if I can switch colors here. Okay, if I wanted to keep this graph going, I would just go down and back up, and down. So this would be, if I wanted 2 cycles of my graph, I could draw it that way, or I could keep going. I could go back up, down, down, and then I have another one over here back up. Okay, so you can make that second cycle go whichever direction you want it to go, either to the left or to the right. And now you have 3 cycles drawn in here. Got 1, 2, 3. Okay, so if you get really good at drawing this first cycle, hopefully then you can just extend your graph in either direction to make your second cycle. Okay, so there's the pretty graph from the book. Okay, let's try example 5, and then I'll do some extra ones in the video notes here for your reference. Whether or not we have time to get to the extra ones in class will depend on how well you guys feel about these graphs as we're doing them in class. Okay, but let's take a look at example 5 here. Okay, this time we have a cosine function. We still have an amplitude, and we still have, do we have a k value? We do. It's just kind of been multiplied into the parentheses. So the way to deal with this is to kind of look at what's inside the parentheses here and take out this value that's in front of the x, like it's a GCF. Okay, so that would be y equals 3/4 cosine of 2x, and then if I take 2 out of 2/3, I would have 1/3, or pi over 3. So if you need to rewrite the function like that so that you can see that k value, that's totally fine. Do that. But know also that that k value is always going to be what's just right in front of this x. Okay, so that k value that's going to affect my period, that's 2. And then I do have a phase shift as well. Okay, I'm adding pi over 3. So that means the graph's going to get shifted to the left, pi over 3. Okay, so let's see if I can write this in. Let's see, I'll do it up here. My amplitude is going to be the absolute value of 3/4, which is 3/4. My period is going to be 2 pi divided by 2, so it's going to be pi. The 2 I'm getting from this number in front of the parentheses, or the number that's right in front of the x there. And then I also have my phase shifts now. So I'm going to take this whole thing that was in the parentheses, the 2x plus 2 pi over 3, and I'm going to set it equal to 0 and solve, and then I'm going to set it equal to 2 pi and solve. And those will get me my starting and ending values in my table of values. So I will have 2x equals negative 2 pi over 3. So if I divide that by 2, I'll get negative pi over 3. So that's where my table of values is going to start. And then I'll have 2x plus 2 pi over 3. Again, the stuff that's in parentheses. I'm going to set it equal to 2 pi. So now when I subtract 2/3 from 2, do that on your calculator if you need to, okay? And this is like 6/3. 2 is like 6/3. Minus 2/3 is going to be 4/3. So 4 pi over 3 divided by 2, that's going to be 2 pi over 3. So when I make my table of values, x and y, I'm going to start at negative pi over 3. 1, 2, 3. And then I'm going to end at 2 pi over 3. Okay, so it's kind of smushed in there. Okay, there's a lot of little work that we have to do ahead of time here. Now, again, to find how much we're going to be adding for each of these increments, I'm going to take my period, which was pi, and I'm going to divide it by 4, because I have 1, 2, 3, 4 times that I have to add a certain amount to go from negative pi over 3 to 2 pi over 3. So pi divided by 4 is going to be pi over 4. So I'm adding pi over 4 every single time. So again, if you need to, use your calculator. Do negative 1 over 3 plus 1 over 4. That's going to be negative pi over 12. and then I add another fourth, that's going to be pi over 6. Add another fourth, that's going to be 5 pi over 12. And then I'm going to have 2 pi over 3. Now, again, this graph might not be the best for our purposes here. Okay, so I'm going to draw this graph. Oh, I still need my y values too. Let's see, normally for cosine, normally I go from 1 to 0 to -1 to 0 and then back to 1. But I have to multiply everything by 3/4. So I'm going to start at 3/4 to 0 to -3/4 to 0 and then back up to 3/4. Okay, so I'm going to start at negative pi over 3. So we'll just say that that's over here. And I have negative pi over 12. And I'll have pi over 6, 5 pi over 12, and 2 pi over 3. So negative pi over 3, and then that'll be the negative pi over 12. This will be pi over 6, and then 5 pi, and then this will be 2 pi over 3. Okay, so just to save room here, I'm not going to label every single one. But again, these are just my x values from my table of values. And then for my y values, let's just put 1 and -1 in here. Okay, and I'm going to have a value of 3/4. So at negative pi over 3, I'm going up 3/4. So maybe right about there, 3/4 of the way. And then at negative pi over 12, I'm going to be at 0. And then at pi over 6, I'm going to be down at negative 3/4. And then back up at 0. And then back up at 3/4. Okay. So it still looks like a cosine curve. It's just shifted to the left. And then it's smooshed a little bit. It's not as tall as it normally is. And our range is going to go from negative 3/4 to positive 3/4. Okay. And if we wanted to keep this going, we could. We can continue adding a fourth and a fourth and a fourth and a fourth, and we could get more increments to make the rest of our graph to do another period if we wanted 2 periods. So there's the nice, pretty graph for the first part, for example 5. Okay, that's the graph that we just did. Okay. All right, now I have 3 other examples here to show you. And again, if we need to do these in class, we can, but I will definitely do them in here so that you have them and you can see them. Okay, so for this first example here, we're going to go through and we're going to find all that information. And let's see, I think I'm going to take out this graph again because this graph is not going to be as helpful to us. Okay, so if this is what you saw in your homework, we want to go through those same steps as before. Notice that here we've got a value in front of our x. So if you wanted to rewrite this, you could. You could take out that 2 like a GCF, and then you get pi over 12. Okay, so take 1/6 and divide it by 2. That's where I'm getting the pi over 12 or the 1/12. And then my amplitude is what I'm going to start with. That's going to be 3. And I'm going to write down my period. Since cosine and sine graphs both have a period of 2 pi, I'm going to divide it by the 2, that value that I took out, or the number that's in front of the x. So my period is going to be pi. Okay. And then I have to do my phase shifts. So I'm going to take all this stuff in the parentheses, the 2x minus pi over 6. I'm going to set it equal to 0. And then I'm also going to set it equal to 2 pi. So I'll have 2x equals pi over 6. And then when I divide by 2, I get pi over 12. And that's the same number that I had there when I took out the 2 from the parentheses. So that's a good double check. And then I'll have 2x equals, I'll have 2 plus a 6. So that's actually going to be 13 pi over 6. And then when I divide by 2, I'm going to get 13 pi over 12. So it's kind of a gross fraction, but that's okay. Remember, that's where we're going to start and end our table of values. Those phase shifts are. So I'm going to start at pi over 12. And then I'm going to have my 3 empty cells. And then my last one will be the 13 pi over 12. Now again, I've got to add 4 times. So I'm going to take my period and divide it by 4. So I'm really adding pi over 4 every time. So do this on your calculator then. So pi over 12 or 1 over 12 plus pi over 4 or 1 over 4 is going to be a third, or pi over 3. Add another fourth, you'll get 7 pi over 12. Add another fourth, you'll get 5 pi over 6 when you reduce it. Add another fourth, you should get 13 pi over 12. And then cosine, remember normally it starts at 1 and then goes to 0, -1, 0, and then back up to 1. But I have to multiply all that, all the y values by 3 for my amplitude. So I'm going to have 3, 0, -3, 0, 3. And again, like I said, the cosine functions always have 2 zeros here in the y values. The sines will always have 3. Okay? And we can tell already that our range is going to go from -3 to +3. We can see that already by the y values. Okay? And when I make my table of values now, or I'm sorry, when I make my graph, okay, I'm going to start at pi over 12, and then I'll have pi over 3. Okay, so you can just write them in, pi over 12, and then it's pi over 3, and then 7 pi over 12, and then 5 pi over 6, and then 13 pi over 12. So again, this is a good one that you want to draw by hand instead of having to put it onto that graph paper. Okay, so 13 pi over 12, that's going to be just a little bit past 1 pi. So this graph should be smushed. It should be really short if you're putting it on that graph paper. Okay, and then we're going to go up 3 and down 3. So at pi over 12, I'm starting at 3, and then I come down to 0, then I go down to -12 or -3, back to 0, and then back to 3. So these are pretty fast to draw by hand. Okay, so there's that one. And if you needed to extend it, you could just keep adding a fourth, a fourth, a fourth, a fourth, and then plot your points. Okay, I do expect you to label those on the graph. Don't just put 4 more lines and then continue drawing the graph. Label those points. Okay. Okay, second example, second extra example if you need more practice. This one is a good one because it has a pi as our k value. So this one's a little bit funkier. Now, I'm going to go through the same process I did for the last one. I'm going to take out my GCF if I need to or want to. So I'll take out the pi, and then I'll have x minus 1/4. So that means that I'm going to shift my graph, okay, to the right, 1/4. So my amplitude is the first value I want to write down. It's going to be the absolute value of the stuff that's out in front there. So that's 2. My period, it's going to be 2 pi. It's still a sine function. 2 pi divided by that pi. So now my period is going to be 2. Okay. And then I need my phase shifts. So I'm going to take all that stuff that was in the parentheses. Okay, so I'll have pi x minus pi over 4. I'm going to set it equal to 0. So then I'll have pi x equals pi over 4 when I add that over. Divide by the pi because I'm solving for x. So I get x equals the fourth. Hey, hey, that's good. It matches what's up there, just like it's supposed to. Okay, so another little double check. Then I'll take pi x minus pi over 4 and I'll set it equal to 2 pi. And then I'm going to add the pi over 4 over. So that's going to be 9 pi over 4. Again, use your calculator if you need to. And then divide. So I'll get 9 over 4. Okay, so that's 2 and a fourth. So when I make my table of values, x and y, I'm going to start at 1/4 for x. Then my 3 blank ones, and then I'm going to end at 9/4. Now my period was 2. And again, I've got 4 times that I have to add. So I'm going to take 2 divided by 4, and I get a half. So I'm going to add a half every time. So 1/4 plus a half is going to be 3/4. Plus a half is going to be 5/4. Plus a half is going to be 7/4. Plus a half is going to be 9/4. Okay, so again, this number here, this x equals 9/4, that should match up here to your very last value after you add all those fourths. Now normally my y values for the sine function, normally I start at 0 and go to 1 and then 0 and -1 and then back to 0. But I have to multiply by this number that was out in front. So I'm going to start at 0 and then go to -2 and then go up to +2. So this is going to flip. Okay. So now when I graph, it's kind of nice now because I'm just putting good old numbers on my number line. So if you wanted, you could put the fractions down. You could also put nice whole numbers and then plot where the fractions are. Okay, so if you wanted to do like every half, like there's a half and there's 1, there's a half and there's 2, there's a half and there's 3, you could. And then you've got 1 and or -1 and -2, and then +1 and +2. So you'd have 0, 1/4, be right about there. Oh, I'm sorry, 1/4, 0. I said it backwards, but I graphed it right. And then 3/4, -2. So it'll be right about there. And then 5/4 or 1 1/4. Come back up to 0. Okay, 7/4 would be almost all the way to 2. And then you'd have 2 1/4 that you could come back down to. So there would be your sine curve. Okay, so that's just another way to make the graph since we have these fractions and we can easily plot those fractions in between whole numbers. You can make your graph that way. If you want to still just write out the fractions and then make your graph, that's okay too. You can do that. And again, our range, can't forget to write that down before we walk away, goes from -2 to 2. Again, our domain would be all real numbers. We can put anything in there. And again, we can extend this graph back, or we could keep adding a fourth and keep it going. Okay, so that one was a good one. In case you see any of these in your homework where there's that extra pi out in front as your k value. Okay, now example 3. This is pretty much as intense as it's gonna get because we have a number that's being multiplied out front, and we have a k value, and we have a phase shift, and we have a number that's being added at the end. So this is as crazy as it could possibly get for you right now. And again, I think I'm going to get rid of this graph because it's not going to be as helpful as just drawing one by ourselves. Okay. All right. So if you want, again, rewrite this function so that you're taking out your GCF, or that k value, which is just the 3. So you could take out the 3, and then you'll have x minus pi over 12. Do 1/4 divided by 3, and then you still have the plus 2 at the end. So if you want to rewrite the function that way, you can. You don't have to. Okay. All right, but we do need our amplitude, so that's going to be the 3 out front. The period, since it's cosine, that's going to be 2 pi divided by that 3 that we took out, so 2 pi over 3. And then we'll have our phase shifts. So for the phase shift, again, it's just the stuff in parentheses, okay? So it's just the 3x minus pi over 4, and we're going to set it equal to 0, and then we'll set it equal to 2 pi. So I'm going to add the pi over 4 over, and then divide by 3, so that'll be pi over 12, which is good because it matches what's in the parentheses there. Okay, that's a good double check. We did it right. And then we have 3x minus pi over 4. Is that equal to 2 pi? So when I add the 1/4 over, that's going to be 9 pi over 4. And then when I divide by 3, that's going to be 3 pi over 4. So this value will be the last value in my table of values, remember. So then I'll have my x and my y. Okay, so I'm starting at pi over 12. And then I've got my 3 blank cells. And then I have the 3 pi over 4, the ending value there for my phase shifts. So beginning phase shift, ending phase shift. Okay, then I have to take my period, the 2 pi over 3. I have to divide it by 4. So you're going to be adding pi over 6. Okay, so again, do that on your calculator. Just do 2/3 divided by 4. You'll get a decimal. Do math, enter, enter. It'll change it back into a fraction. It'll give you 1/6, which is just pi over 6. Okay, so 1/12 plus a 6, that's going to be a 4th, or pi over 4. Add another 6th, you're going to get 5 pi over 12. Add another 6th, you're going to get 7 pi over 12. Plus another 6th, that'll reduce down to the 3 pi over 4. Okay. Now, here's the tricky part for the y's. Okay. We have to multiply everything by 3 and then add 2. So we have to do 2 things to our y values. So normally for a cosine function, normally we start at 1, we go to 0, and then -1, and then 0, and then back up to 1. So I'm going to take 1 and I'm going to multiply it by 3, which is 3, and then I'm going to add 2, which is 5. 0 times 3 is 0, plus 2 is 2. -1 times 3 is -3, plus 2 is -1. 0 times 3 is 0, plus 2 is 2. And then 1 times 3 is 3, plus 2 is 5. So now, this is a good question for you. What's our range? Because it's not just going to be from positive something to negative something, okay? My smallest number is the -1, and my biggest number is the 5. So that's my range now, -1 to 5. Okay? All right, so last thing we have to do is graph then. Okay, so I'm going to go up to 5 and down to -1. And then I'm going to start at pi over 12. And I'll have pi over 4. And then 5 pi over 12. And then 7 pi over 12. And then 3 pi over 4. Okay, so label at least a couple points. Now remember, we're only going to 3 pi over 4, so this is going to be a still very much a shrunken graph. It's going to be all smushed in. Okay, so I'm going to start at pi over 12, 5, and then I'm going to go down to 2, and then I go to negative 1, and back up to 2, and then back up to 5. So there's my cosine curve. Okay, so that had a lot of stuff going on in it. That's pretty much the whole shebang for you. So if you were able to follow along with that example, you knew where all those numbers came from, you were able to graph, you understood the range, then you're in good shape. So here is your homework then for 5.3 day 2. Okay, they're all odds. Check them in the back of the book. But you really need to practice these, and you really need to pay attention to all those little details. Okay? The graphs and the tables and all the work is all worked out in the binder in the classroom as well. So if you want to look at that, help yourself, and do stop in before school and see me if you have questions.